Hey guys, good morning. Thank you so much for coming to Cisco Live. I know it's been 3 years since we had our last Cisco Live in US, right? And I know a lot of things have changed around the world since then. So to each one of you, first of all, I'd like to personally thank you for coming to Cisco Live, taking this moment and giving me this opportunity to present this session to you. I hope that you find it beneficial. So my name is Parth Patel, and I'm a technical marketing engineer with Cisco's Cloud Networking BU. And I primarily focus on anything which is VXLAN, EVPN design architectures. And from control and automation point of view, I also look for NDFC and NDO. So on day-to-day basis, I work with many customers like you, right? And I try to understand the challenges and the pain points that you face to operate your data center fabrics. And then I work closely with the engineering team to build and ship the products which solves your use cases. So I've been with Cisco since last 2 years. And before that, I was a network engineer, like most of you, for 3 years. So I can totally relate with you, and I can understand the challenges that we face in our operations. So quick one. So we have this WebEx application team that you can access from the Cisco Live events page. So you can join the discussion. So if time doesn't permit today, because we have a 45-minute session, so feel free to ask any questions about the session or the product that you have, and I'll be more than happy to go over the questions. At the same time, also download the latest PDF deck, which I have posted in the Cisco Events tab. It has more than 100 bonus slides, okay? So it covers the complete picture of NDFC product, right? It's quite detailed. Look it up. It's a good educational material. It's also helpful for your training as well. You can just use those slides and go home and practice on your NDFC and get well-versed with that. All right. So today's agenda, right? So first, I want to start with introduction to NDFC. Like, what is the problem statement? Why do we need to build this NDFC as a tool? What are the problems it's trying to solve, right? Then we'll go into the install and deployment and the best practices of NDFC, right? What are the different ways to do it? Then we'll go into the 3 key features, which is how to use NDFC to do fabric automation. And I'll show you a quick demo. Then we'll go into the fabric management and visibility part. And finally, I'll conclude with the licensing. OK. So to start, I want to set up some context on the strategy and the roadmap that is driving NDFC. Okay? So as data centers are becoming more popular in different locations or any location where data is needed, whether it's a public cloud, on-premises, edge, colo, and beyond. At the same time, the data center management and monitoring requirements are rapidly changing. It's becoming more complex and demanding. So this creates challenges for any IT operations to meet the IP SLA, avoid the downtime, and at the same time, meet the scaling requirements. So many customers like you are looking for some tools which helps you meet the ever-growing demand of data. In today's IT world, the top priority is to automate at scale, have complete visibility into the infrastructure, and remediate the issue. And that is where we are building the NXOS dashboard fabric control. Now, there are many tools out there which may solve our problems, right? But it's always in bits and pieces, right? The biggest burden for IT admins is to stitch and correlate this information across these numerous tools in that hybrid environment and maintain the cost of this lifecycle stacks. So, and we know what exactly happens next. It results in broken user experience, failure in identifying the problems proactively, which then leads to business downtime. And this is what we are solving with NXOS dashboard. So with that, I'm really excited to announce the next generation of DCNM, which is now rebranded as Cisco's NXOS dashboard fabric controller. I know we like long names. It's just Cisco, yeah. OK, so before that, how many of you are aware what is NXOS dashboard? OK, few. OK, got it. So the first question that comes to our mind is, right, why the rename, right? Why don't you just keep DCNM, right? Why you had to rename NDFC? What is the idea behind the renaming? Where is the cloud networking strategy going, right? All those things. So think of NXOS dashboard as a unified platform, right, where you can host all your service application. So it gives you that single launch point to monitor and scale across different sites. Like, for example, NXOS dashboard orchestrator talking to multiple NDFC controller at the same time, so you can do intent-based networking. Or you can integrate with Nexus Insights, which provides the 360 telemetry view of your network infrastructure. Hence, ND or Nexus Dashboard gives you that single pane of glass so that you can automate, scale, visualize using all these different services on it. And now one significant change that is coming with NDFC 12 is it will fully run on top of Nexus Dashboard. And it joins the other application so that you can have the single sign-on and simplified user experience across the entire cloud networking software portfolio. Okay, so now we understood different challenges and problems we face in our modern IT world, right? So let us see how we are solving this with NDFC. So NDFC is a comprehensive management solution for all NXOS network deployment. It spans across LAN, SAN, and IP fabric for media. With the latest edition of NDFC, we are focusing on 3 main topics. That is automation, visibility, and management. When it comes to automation, NDFC accelerates any kind of deployment, like creating your VXLAN EVPN fabric within minutes, or creating your VLAN, classic LAN architecture, VPC, fabric part, doesn't matter. Even eBGP-based routed fabrics, ISXC-based fabrics, right? Now, when we automate, it's very important for us to know what exactly was automated, right? We need to have that visibility. So that's where the visibility comes to picture. It not only shows you what configuration you pushed on the switches, but it gives you the entire topology and inventory of how your switches are connected together in your fabric, along with your virtual environment. So say that you have an ESXi and some VMs on it. NDFC will give you the complete topological view to show you that how your ESXi servers are connected to with switches. Last, as we automate and visualize, it's important that we ensure we have consistency across the platform. And that's where the management and the compliance come. So in NDFC, we have a special container which runs as a configuration compliance. That compliance makes sure that the running configuration of the switches matches with the intent of NDFC, so that you don't have any issues with sync or out of sync. And the moment any configuration which was done outside of the scope of controller, it will show you in a different color, and it will tell you that everything is out of sync, and it gives an option to remediate it, the configuration, right? All right, so now let's look into different options on how we can install and deploy our NDFC application. Now, one major change is with NDFC, we have introduced this new feature, which is a feature management. This allows you a new way to deploy and enable your features. Now, how many of you are running DCNM right now in your environment? Okay, few. So if you recall, in DCNM, you had to make an install time choice, right? To whether go with LAN fabric or SAN or media fabric. Now, what if you want to go from LAN to IPFM and vice versa? You have to redo the installation. It's not possible. With NDFC, everything is possible. We have created 3 different personas: fabric discovery, fabric control, and SAN control. Everything under the same service application. So now, all these features can be enabled at the runtime rather than install time. So this gives you an ability to enable or disable the feature as you go. So for example, the fabric discovery is a lightweight feature which allows you to just onboard your switches and just have this topological view of the fabric. No configuration, no automation, no compliance, just visualize it, right? Because you have some other ways to automate it. So that gives you that capability, and it also allows you to stitch that fabric to the NDI. Because remember, Nexus Dashboard Insights, it requires to understand the topology. Whether it's a VXLAN, it's a classic LAN, what is the hardware, what is the switch role. So based on that, it will send the telemetry configuration, right? That's where the feature comes in. Second, we have the fabric controller. Fabric control is everything what fabric discovery provides and more. That means you have full automation, compliance, and management capability on that feature. And last, we have the SAN controller, which allows you to manage and operate your SAN fabrics. Now, by default, when you go to the fabric controller, you will only see this last feature, which is recommended by the controller, which is fabric builder. So this, again, is a microservice, right? It allows you to create a VXLAN EVPN fabric. So it can be, again, classic LAN, VPC, eBGP-based routed, ISXC fabrics, doesn't matter. The other features are disabled by default. So you can always enable or disable on the runtime as you go. So this gives you a better usage of your ND compute, because you don't want to use all the 100% of your resources on day one. You want to see that, okay, my use case is just to automate, let's say, VXLAN fabric. I don't want performance monitor, I don't want my VMM visualizer, because I have some other tools which provides me that data. So that's fine. You can just enable the fabric builder and start from there. And after 3 months, maybe you can do some POC, you can see how the feature works, you can come back and activate it, and that's fine. And one important thing to keep in mind is when you activate any of these features, the respective microservices container spins up on the NXOS dashboard. So it has this YAML file, right, which includes the specs, the minimum, it's like a request and all those things which happens with the ND master nodes. So it talks to the NXOS dashboard master node. NXOS dashboard master nodes runs a spatial Kubernetes-based scheduling algorithm to say that, okay, do I have the resources to spawn this particular pod? If yes, then I will enable it. And the moment it enables it, you will see the dynamic menus on the left-hand side. Okay, so for the form factors, again, with NDFC, we are getting a revamped architecture, right? So with DCNM release, DCNM is based on a pseudo-monolithic, right? It's an active standby architecture. It doesn't give you the true active horizontal scale-out ability. Even though there were 2 nodes, but one of the nodes was active, the second one was standby. So all the operations was done on the active node, though we had to reserve and use all the resources. But eventually, we're not using it, right? Because everything was done on the active node. With NDFC, everything is active architecture. Because NDFC is completely cloud-native microservices solution. Everything is based on the well-known Kubernetes construct of pods, nodes, namespaces, and everything. These containers gets instantiated the moment you enable that respective feature. And remember, only that feature will be enabled, right? So you have that control on the product. You as a network admin, you can dictate the product on how it will look like, how it will operate, right? Now, there are 2 main options you can deploy NDFC on top of NXOS dashboard, right? Again, remember, NXOS dashboard is the platform, just like our smartphone, right? You have the smartphone, on the smartphone you enable the apps. So NDFC is app, smartphone is the NXOS dashboard, simple. So NXOS dashboard, it's a 3-node cluster to start with, right? All 3 are active. You can either do virtual or physical. With NDFC 12.1.1, which we actually, I think so, shipped last week, right? You can now scale up to 400 switches. So you can do 3 physical node and get 400 switches. Or if you prefer the virtual on ESXi or KVM hypervisor, you can just simply go with 5 END node as well. Okay, installation. So first step, as I said, right? Let's install the NXOS dashboard cluster. So 3 nodes, all 3 will be masters. This is the base requirements. This is where we start from, okay? Then you can choose whether you want to do an OVA profile or whether you want to do the physical appliance. And once that is done, you go to the app store. Just like your smartphone, you go to the NXOS dashboard, there's the app store. On the app store, you just locate the NDFC application, click on install, click on activate, and you're done. Just 2 steps. Okay, now there are 2 types of networking that we support with ND. One is the layer 2 HA, and there's the layer 3 HA. Now in the layer 2 HA, there are 2 interfaces on ND. So one interface is the management interface, and the second interface is the data interface. So in the management interface, it allows you to access the ND UI, right? Allows you to do firmware upgrade of the NXOS dashboard or the service application itself. The data interface allows you to do the clustering. So you have to form the cluster between ND node 1, 2, and 3. So that's where the data interface talks. And then, of course, the application to application. Remember, NDFC also talks to NDI, NDO, all these different applications. That inter-app communication, like Kafka messaging, internal API calls, everything happens over the data interface. Next, of course, the fabric and the management. Fabric or the data, they are interchangeable words. So management and the fabric interface must be part of a different subnets. On each interface, all the NXOS dashboard will share the same network, right? This gives you the layer 2 HA functionality. Now we have this persistent IP requirement, right? So there are some certain special pods that runs inside NDFC, okay? And they require an IP stickiness requirement. So what is this? So for example, when you import a switch into the controller, the NDFC puts itself as a SNMP trap, okay? Now you don't want to reprogram every time there is a failure in the SNMP trap pod. So today the SNMP trap pod is running on node 1. If it fails, it goes to node 2. So every time it fails, you don't want to reprogram the trap configuration switches. So that's what you do. You provide IP stickiness, and that's where the persistent IP comes into the picture. So now persistent IP address can be enabled either on the management side of the things or in the data. But certain feature requires a data interface, which is the endpoint locator. So that's where you activate that particular persistent IP address. And finally, we also support the physical ND option, right? Physical ND option also works the same way like virtual. Nothing changes. All the principles also applies there. Now we have the layer 3 HA that we introduced again with 12.1 last week. Layer 3 HA, same concepts. We have two interfaces, management in the data. Now, we still have to keep the interfaces in a different subnet, but the clustering now can be across different network. So now you can have the ND node 1 in data center 1, node 2 in data center 2, and node 3 in data center 3, because you have layer 3 HA between them. So you don't have to do any layer 2 clustering. Everything can be done over layer 3. And for persistent IP address, we are using BGP. So we are running BGP on the NXOS dashboard. So that NXOS dashboard advertises the persistent IP address as a /32s towards your upstream switch. So if one of the pod goes down, the next pod will advertise that /32. So because it's a /32 route in the EVPN, we know exactly what's the next hop and which ND to communicate to. All right. So now, two common ways to connect your switch infrastructure to the NDFC, right? So the first option is that you have the MGMT0 interface in the same subnet or different subnet than the ND management. So now you have this end user, right, who is connected to the ND and NDFC via the management interface. So management interface is also called as a bond 1 interface in the terminology of NXOS dashboard. So it gives you SSH, HTTP, DNS, all those access. Second, the same interface connects to the OOB network, the management 0 interface of the switches. So that way you use the ND management interface to onboard the switch using the switch management 0 interface. And then you have the bond 0 or the data interface, which is used for the in-band communication. In-band communication use case is mainly for telemetry, PTP, endpoint locator, all those things. Second option, now, instead of using ND management, we are using the ND data interface. So how that works? You will still use the ND management for your UI access, firmware upgrades, all of these things. But now, you will be using the data interface to communicate with the OOB network of your switches. So your management 0 interface of the switches will now interconnect with the ND data interface. So that gives you discovery, deploy, monitor, image management, and all those features. And of course, you can also get PTP and telemetry with in-band access as well. Okay, so now NDFC supports full distributed architecture, right? So you can have clusters in different geolocations. So when you build ND clustering, there are certain roles that we need to keep in mind, right? So a node can be a master node, a worker node, or a standby node. Master is the main brains of the cluster, right? It forms the cluster. It handles the control plane operation of the cluster. It runs that special Kubernetes algorithm based on the request and the limits. The pods and the microservices tell that, hey, I want to get spin up. These are my requested specs. This is the minimum memory and CPU I'm requesting. Please help me get instantiated. NXOS dashboard master node makes that decision. Second, we have the worker nodes. Worker nodes essentially helps you to do the scale out and horizontal application. And then finally, you have the standby. Standby nodes is mainly used when there's a failover. For example, if one of the master node goes down, then you can promote the standby to the master. And remember, only the standby can be promoted to master, not the worker. So in this example, I have two masters on one data center, third master on the second data center, standby. So if one of the master goes down, then whatever pods that were running inside that master, it will be automatically respawn on the remaining two master nodes. No user intervention, everything handles at the kube level. And then what you can do is that you can promote this standby to the master. So now again, you can regain that 3 node cluster. From failure point of view, yeah, question.
So you can't have 4 masters, you have to have 3 masters.
That's correct.
Standby, correct? Is that standby when you said it gets
Okay, so the question is that if master goes down, then we need to promote the standby. That process is automatic or manual. Today it's manual. So you go to either one of the master which is active, and then you just click once that promote, and then it will promote itself from standby to master.
Thank you.
Yeah. Yes, next question. Yeah, that's for the VND. Okay, so the first diagram is for the physical. Remember, you can have the cluster either physical or virtual. For physical, you can have just 3 master nodes that will give you full scale support of 400 switches. Today, we do not scale more than 400 switches, right, with NDFC. For full scale, you can just go with 3 master nodes and you are done. Now, from the failure point of view, if 2 master goes down, that's when we'll have the impact of the application. Because now the application itself will go into read-only mode. In that case, you need to first promote the standby to the master, right? So when you do that, you need to make a decision. Because remember, right now in cluster, there are 3 masters, M1, M2, M3. But now M1 and M2 both died. So now you have to make a decision whether to kick M1 out or M2 out. So let's say you kick M1 out of the cluster, so that will give the room for the standby to join the cluster. So now you have M3 as a master and standby, and then when M1 comes up, it cannot join the master because there is already 3 masters up and running.
So
yeah, question.
deployment, do you have to have 6 nodes, or can you have less or more?
So for full scale of 400 switches, we need 5 virtual nodes and plus 1 standby. So that's why you have 3 masters and 2 workers.
But if you don't have 400 switches, could you run more than 400?
So if you have less, if your switch count is from 80 switches to 400, then you need 5 node VND. Anything which is less than 80 switches, you can just have 3 virtual node as well. Yes, question.
Is there any scale?
It's been planned for the next release. We are planning for up to 500 switches.
Can you run multiple clusters then? Have separate clusters managing different, like say you had 2 pods in a data center, each of them had 400 switches in it. Can you run multiple instances and have everything tied together like with the NDI and all that?
Yeah, so the question is that can you run multiple instances of NDFC? So NDFC will have a single instance on a cluster, but you can have multiple clusters managing different data centers. And you can stitch together using NDO. Yeah. Okay, so next we'll talk about one of the key features of NDFC, which is automation. So NDFC automates the entire life cycle of fabric technologies such as VXLAN EVPN, classic LAN, massive scale data center architectures, eBGP routed fabrics, and more. So with that, you can also automate the configurations which are related to peer for the service node. So if you have firewalls, load balancers, and you want to see the configuration on the switching side, you can configure the static routing, BGP routing, which will help you onboard those service node as well. And another use case is for the layer 3 out on the WAN use case, right? So you can use VRF Lite to extend your VRF tenant from your data center fabric to the WAN or the backbone. Last but not the least, NDFC is also a DevOps friendly tool where you can leverage the UI or REST API to make all the configuration changes. Inside the NXOS dashboard, we have a special tool which is a Swagger. It's like a REST API Swagger tool, which you can use to test and see the live API calls when you do the automation. Based on that, you can even create your own automation framework which sits on top of the NDFC. And it also has full integration with Ansible and Terraform, which allows you to do common day 0 and day 1 tasks as well.
Different are the API calls to NXOS dashboard from BCN?
Yes, great question. So the question is that how the API calls are different from the NXOS dashboard compared to application which is NDFC. So in the API, there is a prefix which clearly segregates whether that API call is for the platform or for the application. So if this is just ND, that means you're making calls on the API ND platform. If it's /NDFC, it goes to the inside of the application. Same way, you have NDI, NDO, all of this segregation. Okay, so now next, let's quickly go over a demo that I would like to show to see how NDFC simplifies provisioning and automates the greenfield EVPN fabrics in minutes using Cisco's best practices. Okay. So I have this NDFC application up and running inside the Nexus dashboard cluster, right? So we need to install it, we need to activate it, and once that is done, I'll open it. This will cross-launch us to the home page of NDFC. So the first step is to create a fabric, right? So this is our day 0 operation. So go to Actions, click on Add Fabric. I'll provide a name of a fabric. It's a definition of a fabric. Then you choose the template. Now you see there are a lot of templates available, right? So templates is like a definition of your fabric. It tells you that how your data center looks like from connection point of view, from architecture point of view, and also from configuration point of view. So the first we have Easy Fabric. That gives you VXLAN EVPN for Nexus 9000, 3000. Second, we have the IOS XE. So that gives you a complete VXLAN EVPN for IOS XE boxes. So now we can also automate Cat9K, everything, right? Then you have the eBGP. So that gives you VXLAN EVPN, but with eBGP in the underlay rather than iBGP. Then we have the External Fabric. External Fabric allows you to do monitoring and manage for VPC, fabric path-based networks, third-party switches, IOS XE, CSR, ASR9K, all of this goes into the External Fabric. Oops, I think so. Okay, just went back. And the last one that you see is the MSD fabric that allows you to stitch multiple easy fabric together. So that way you can have the VXLAN EVPN multi-site between 1 or 2 ports. So I'll select the easy fabric. Now you see the system is only expecting me to provide a single input, which is the BGP ASN. And that's it. Once I provide the BGP ASN, I don't have to change any other fields. But now if I go down, all other fields are auto-populated and recommended by the NDFC. Again, these values are Cisco's best practices. That's it. But you are more than welcome to change it based on your organization's goals. So for example, in the underlay protocol, I can use OSPF or ISIS, right? Similarly, in the replication, I can go with the multicast or ingress replication as an option. In the advanced tab, I can go with overlay mode of config profile or CLIs. Now, anyone who is using config profiles right now? Okay. Yeah, so now we also have an option to do CLI. So instead of bundling all those configuration together, NXOS and NDFC will communicate using the CLI. So NDFC will push everything together in the CLI hierarchy rather than profiles. Next, in the resources, it gives you a complete IP address management for every object of your VXLAN fabric, right? So you see that it provides you a pool for loopback 0, which is used for your router IDs, OSPF, BGP, control plane sessions, right? Then you have the VTAP for the data plane, for the loopback 1, which goes on the VTAP leaves. Then you have the RP, if you're running multicast, it will be grayed out if you were to select ingress replication. So it does this automatically in the backend. And finally, you have the point-to-point subnets between leaf and spines. Same over here, you can see the labels that it will auto-locate from the resource manager. So it runs a special pool, right? Resource manager pool. It keeps a track of how many switches you have. And based on the number of switches, it allocates the first available label to those switches. So over here, you can see the layer 2 VNI, layer 3 VNI. All these details can be editable, or you can just keep it at default. Next, in the bootstrap, you can optionally enable bootstrap if you want to do it, else you can just go with simple seed information that I will show in the demo. Configuration backup shows you that if you want to do a backup, fabric-wide configuration backup, either hourly or scheduled, right? And then once you want to restore it, you can restore the full configuration on demand, right? So now I'll go back to the general parameters. Again, remember, the red one is the only one which tells me that one single input is needed. Rest of the fabric is auto-created by NDFC. So I'm just going to provide BGP ASN and save the fabric, and that's it. My fabric definition is done. So now I see a cloud which is created with the name of VXLAN data centers. The second step is to add the switches, right? So we go inside the cloud, and right now you see I don't have any objects. I have 0 verbs, 0 networks, 0 switches. So this is the first step, that we add switches. Click on Add Switches, and now I'm providing a management IP address of one of my lab switch. So the NDFC is connected to the OOP or the management user interface of these switches, and I'm then providing the username and password. This username and password is like a discovery credentials, which NDFC uses as a combination of SNMP v3 and SSH to log into the switches, find out how things are connected with each other, what is the base details of it, what is the host name, what is the platform, what is the NXOS version, all of these things will be discovered now. And then I have the max hop of 2. So this tells me that NDFC should log in to the switch 100.62. From that 62, try to discover every switch which is 2 hops away from you. And then I have the last hop, which is preserve config. So there are 2 ways again to import a switch. One is by checking that box, which is by default, which tells that you are using VXLAN EVPN brownfield, right? You might have production VXLAN by using some other tools like CLI, and now you want to use NDFC to manage it. So that's when you'll be preserving the config. But in my case, it's a greenfield. I don't care about my configuration of switches. It's fine. I want to keep it greenfield. Maybe I was playing with the configuration, I'm okay with it, and now I'm confident to go with the controlled approach. So I'll just disable that box. And then I'll click on discard switches. Now when I click on discard switches, it gives me this pop-up warning, right? Saying that all the configurations will be removed except management. And why did? Because we disabled the check. And we want that, right? We want NDFC to clean question.
What's the authentication protocols support? Only MD5?
No, there are a lot of like SHA, there are multiple protocols. Yes. Yes. Question.
Is the username and password for SNMP v3 or?
Both. Yes, it's for both. So when you do discovery, NDFC does, so question is that the username and password is just for SNMP or for SSH also, right? So the answer is that NDFC does the shallow discovery based on a combination of both SSH and SNMP v3. So in the NXOS, when you create a local username, the NXOS software itself creates a corresponding SNMP user with the same credentials, okay? So you don't have to do it manually. You just do username admin, password this, and the same SNMP user is also created. So try do show run and it will see that. But if you're using AAA authentication, then there is no SNMP involved. In that case, NDFC, when it tries to SSH, it will say that, oh, this is AAA. Okay, so there's no SNMP. So what it does, it will create a command, sync SNMP. So it automatically syncs that password from the AAA and it does the discovery on it. So the question is that do you need to set any privilege? No. You just need to make sure that this is, for discovery, you don't need to set any privilege because this is for discovery. For LAN credentials, it has to be the admin. Yeah. So we'll confirm it. And now it does the SSH and SNMP discovery. Now you see that it discovered this 5 to 6 switches. Remember, we just need to provide the 62 IP address. And it discovered the rest of the topology based on LLDP and CDP. And now you see all the details like model, the version, it's manageable, and then I'm going to click on add switches. So now you see that the switches will be rebooted and they will be added. Now, NDFC automatically creates this class architecture for you, right? It knows that what is the role of the spines. In my case, it was 9500 and the leaf was 9300, right? So it knows that 9500 is always spines. It's a modular chassis. It's rarely going to be leaf. So it automatically creates that role as a spine. And by default, we kept all the role in the fabric as leaf because we don't want users to manually go to each and every switch and change the roles. Because when you create a VXLAN fabric, which is the most common role that you use? Leaf. You'll always have 100 leaf. You'll never have 100 spines. So that's the logic that we put in the product. Now, I also have a border devices which I want to do it. So what I'll do is that I'll use the multi-select option. And I will select border 1 and border 2, and I will set the role. Okay, so now you see the NDFC has created this topology for you. Now, even though from physical point of view, everything connects to the spine, right? But why I'm seeing border on top of spine? Again, topology. Any traffic which comes inside data center or goes outside data center, it always goes by the border. So we want users to have that visualization from traffic point of view as well. Once that is done, we can do VPC pairing. So how fast is VPC pairing? Just right click on the switch, click on the VPC pairing, and that's it. It will give you all the roles, all the devices that are part of a fabric, okay? It will give you a recommendation whether it's eligible to do a VPC pairing or not, and and, you just select the leaf. and then click on save.
Will it be virtual?
Question, yeah.
Will it be virtual on VPC or physical?
You can do both. You can do fabric peering or virtual. So question is that, does NDFC does virtual fabric peering or regular peering VPC? It supports both. And we also have checks in the backend which make sure whether the destination device is compatible from code point of view and also from hardware point of view. Yeah, question.
Yeah, I found that if you rule set and you deploy it, it's difficult to change it. Like if you deploy it as a leaf, you can't change it to a spine.
Yeah, so the question is, yeah, so because that's the reason is because if you have already an overlay. So if you have VXLAN overlays like WRF and network configured on the leaves, you cannot change the roles because it's a disruptive operation.
Okay, and that's going to be that way going forward. So basically,
Yeah.
you have to delete it and re-edit
Yes.
it it's in the wrong role.
Yeah.
Thank you.
Is that the general rule of thumb for any disruptive operation happening in NDFC? That it won't let you do it until you redeploy?
Yeah, so if you can just hold that question, there's a NXOS technical explanation that I can give because I just have we have 10 minutes, so I just want to finish this up. I'll come back to that. So next we'll do the recalculate and deploy. In the recalculate and deploy, what NDFC does is that NDFC runs this configuration compliance in the backend. It knows that how many switches it has. Remember in the first step, we saw that pool, loopback 0, loopback 1, right, all this pool. It figures out that which IP it needs to allocate on which devices. It uses in the round robin fashion. And then it creates this side-by-side comparison between the running configuration of switches versus the pending configuration. So this is the pending configuration of the switch. And similarly, we'll see also the running configuration of the switch. So it creates this router ID for you, the VPC domain, the port channel, and this gives you a side-by-side view between the running configuration and the expected configuration. Oh, sorry, my bad. Actually, excuse me. Something wrong with the system. Let me just restart it. Sorry, my bad. Okay. Sorry. So for some reason, I can't restart my demo, unfortunately, in middle. So I can't restart it from here. No, not from beginning, not from beginning. Yeah, okay. I need this, yeah. Thank you, yeah. So now you see, sorry about that, guys. So now you see a side-by-side difference between the configuration, we saw this, and it will deploy on the switches, right? So you see the live deployment status on the UI, and now the next step is to create the overlays, right? So remember, the D0 configuration is complete at this point. You add the switches, you set the role, NDFC creates the BGP, OSPF, all the VPC configurations, interfaces, everything is done in the day 0. Now for day 1, we'll be creating the overlays. So I'm creating a network. So the only thing you need to provide is a network. So now I don't have a WRF, right? So I'm going to click on WRF. And option, you can also do a route targets. You can do auto, or you can create your own custom route targets. And then you can provide the Anycast gateway for that VXLAN network. And then simply click on create. So now you have this via network and VRF definition. So now remember the switches. What's happening? Okay, so the switches right now are in gray. Previously you saw in green, right? So that green is for the day 0, not for day 1. Today the network is not yet configured on the switches. So that's why you see different colors of the switches. It's not in green because it's not applicable. It's not configured there yet. So I'm going. the same problem. Okay. What's happening? It's the same problem of the video. It's not working, man. Where the hell is this? Huh? Yeah. Duplicate. So where should I click? Can you just stay here? Okay, so now you see we are going to attach the networks. So you select the switches, you click the edit attachments, and from here you provide the ports on which you want to extend the network, right? And then you click on save, and then you go next. Similarly, for the third leaf, you select the interfaces that you want to attach this network to, and then finally click on save and next. So you see now the configuration has gone into the blue, which is the pending state. And again, configuration compliance runs in the backend. It does this side-by-side comparison between the running configuration and the intent of the NDFC, and it provides this overlay for you. And then finally click on deploy. So that's how you can quickly do the day 0 and day 1 provisioning with NDFC. Now for the management, right? Just quick question. I need to put the notes. Notes view.
You can have notes and see.
No, I saw it before it was working.
This is the video?
Yeah. No, notes on the slide. Yes. Okay. Sorry. Okay. So now in the NDFC management, so now when we build data center, right, we need to host different kinds of traffic, right? Some data center fabrics can carry production traffic. Some data center fabric can do POC or staging traffic, right? So based on that, we need to ensure that we give right administrative access to the right amount of team. So with NDFC 12, we are introducing a new granular RBAC role where I can be a network admin for fabric A, and at the same time, I can be a network stager for fabric B as well. So this allows you to provide a granular control at the RBAC level. Now, image management, right? So we have completely streamlined the image management lifecycle with NDFC. So as you know that it takes several cycles for you to perform a switch manually upgrade, right? And it's prone to error. So how are we improving this stuff? So we have 4 questions to it. So first of all, why it's so important? Because upgrading manually takes long time, it's prone to error, creates a lot of issues in the operations. And how does it work, right? So NDFC streamlines the entire image management lifecycle by creating different tasks. So it stages the images, it validates the images, everything is done before an actual upgrade starts. So it allows you to perform 80% of your task before an actual maintenance window. At the same time, it allows you to run programmable reports. So programmable reports takes the snapshot of the current running configuration of switches, okay, and what is the state before an upgrade, and then you can compare that state after an upgrade as well. So it automates the image management lifecycle for any Nexus switches, like Nexus 5K, 6K, 7K, doesn't matter. And then finally, you can do on-demand or it's a scheduled one. So let's quickly look at the process. So first step is that you upload the images on the ND, right, and the NDFC. Once you create it, you create an image management policy, whether that image is for Nexus 7K or it's for the Nexus 5K or Nexus 9K. Once you create the image policy, you attach that image policy to the respective switches. Okay, so that's the third step. Once that is done, we stage the images. Everything is now automatically done on the controller. And the moment you do all and each steps, you see the live logs on the UI. So you don't have to log into the switches to verify anything. And if for some reason switch responds back with error, you'll also see that error on the web UI. Once the staging is done, you validate whether it's a disruptive or it's a non-disruptive, right? Against the current NXOS version, it also shows all the warnings and messages on the UI. And finally, you can upgrade the switches. I'll come back on this, sure. Okay, so I also want to talk about non-Nexus support, right? So with NDFC 12, we are extending the support. We are extending the support for IOS XE and IOS XR fabric. Okay, so in IOS XE you can do full automation, VXLAN EVPN with NDFC. We created a new fabric template just for this specific use case. So you can have your campus networks running at least 9,000 and do VXLAN EVPN on top of it. And also we can do the managed mode of IOS XR. So in the management of IOS XR, you can do the VRF-led use cases between the NXOS and the IOS XR boxes. Yeah. Okay, so quickly on the visibility side, I want to show you the virtual environment. Right? So in a typically virtualized environment, any kind of troubleshooting starts by identifying the network attachment points. Network attachment points where your application is, right? So there are different stakeholders in data centers. Some operates the network infrastructure, while some operates the virtual infrastructure. So we need a lot of coordination and communication between them when we do the troubleshooting. So with that, NDFC provides you a single pane of glass solution to give all this information together, so you don't have to, navigate between different tools to get all this information together. And finally, we also have an endpoint locator feature which allows the real-time tracking of any endpoint within your data center, whether it's a VXLAN EVPN single site or it's a multi-site. So this allows you to troubleshoot any endpoints. It gives you endpoint tracks such as what is a MAC move, what is the MAC and IP of that, where that endpoint is connected to, which switch, what is the configurations, what is the statistics, when was the last endpoint detected on which switch, how it moved, what time. All this information is shown with the endpoint locator feature. Now, finally, I want to close with the licensing part. Now, in the licensing, we do support both server-based license and the switch tier-based license. So if you have any essentials, advantage, or premier licenses on the switches, NDFC will discover those licenses and it will give itself as a right to manage. But let's say if you have DCNM, in the DCNM, we were running server-based license, and that was attached to the MAC of the Ethernet 1 port, right? Now, in the NDFC, there's no concept of MAC address. It's a Kubernetes, it's a microservices-based solution. So what do you do? The first thing you do is to convert those server-based licensing to smart licensing using the Cisco's CSSM portal. And that gives also you the right to manage the switches. And some summary and benefits, right? So with some conclusion and some key takeaways. So today we discuss how NDFC's next generation active-active microservices allows you to scale up and scale out by running the runtime feature, and how you can easily deploy different nodes across different sites with the clustering, right? And in the automation, we saw how quickly we can provision a VXLAN EVPN fabric from scratch. From management point of view, we saw that how we can create different rollbacks, different RBAC to segregate the administrative control of our data center fabrics. And also we saw that how NDFC gives you an ability to manage non-NXOS switches such as IOS XR, IOS XE with different use cases as well. And finally, in the virtual environment, we saw that how NDFC shows you that single pane of glass to have that complete visibility of your virtual environment and the physical environment as well. So with that, thank you so much.